Write the problem.
Okay, so
Yes.
3x squared equals 2x plus 3. And it asked me to turn the right equation, use the formula to solve it.
Good.
So I did it.
So we have a quadratic equation, and we're asked, they indicate the method in this case. Well, obviously, when you're asked to use a particular method, I recommend use it as a practice. But of course, when you put in the solutions, nobody will check which method you used. However, it's very important to understand which method is the best in which case to apply, of course, right? So that's always the. So in this case, we are asked to use the quadratic formula, correct? Okay. So what is the first step, mandatory step?
You subtract the 2.
Yes, I have to have 0 on one side. This is the first step for quadratic formula. Then we have to identify a, b, and c. So we have negative b, which is positive 2, plus or minus the square root of b squared minus 4 times a. But since c is negative, I'm going to change this into positive, so I don't have to put too many parentheses, over 2 times a, which is 6. Now, I would like to show you what I would have done with this problem, because you will probably, most probably, ask us to fully simplify. Okay, so let's look inside or under the radical. I see 4 plus 4 times 3 times 3. From these two terms, I can factor out, and you can say, why can't you use the calculator? I'll show you why I'm not using the calculator. So from these two terms, I can factor out what? Excellent. What is left? Something must be left from the first term, and something else must be left from the second term. So I have to have plus between these two terms. From the first term, 4 times what is 4?
1.
Correct. 4 times what is 4 times 3 times 3? Obviously 3 times 3, which is 9. So then the answer for now is 4 times 10. I want it. Why? Because if I write it as 4 times 10, I can simplify it easily. If I write 40, I still have to write it as 4 times 10 anyway, in order to simplify the radical. So I'll write 2 plus or minus, the square root of 4 is 2, and the square root of 10 is the square root of 10. At this point, I have to continue. And not by simplifying 2 with 2. Be careful. You have two options now. One option is, I don't have any specific preference. Yes?
See, this is where my question was, because before we stopped right there, right?
You can, because you have 2, 2, and 6. So you have two options now. You either write 2 over 6 plus or minus 2 the square root of 10 over 6, and you simplify each fraction by itself, or you factor out a 2, you get 1 plus the square root of 10 divided by 6, and you simplify by 2 again. So you will get the same answer, written two different ways. The first way will be 1/3 plus or minus the square root of 10 over 3, which is acceptable. And the second one is also acceptable, 1 plus or minus the square root of 10 divided by 3. But you have to continue. It's not fully simplified. The 2 plus or minus 2 the square root of 10 and 6 in the denominator. Now, don't change anything. But let's say I had here a 5. Then you could have left it as is, because 2 and 5 and 6 don't have a common factor. But 2, 2, and 6 have a common factor. But one thing I am begging you not to do, right? To do something like this, 1 and 3. That will be a terrible mistake. Why? Because we are not allowed to simplify terms or pieces of a term with a factor. So you cannot remove this with this. Say, I divide 2 by 2 and 6 by 2. You cannot do that. Very good question. Thank you. Oh, no. Very good question. Because I'm sure everyone else will encounter this. So discussing it in class is the best. Excellent. Very good question. Anything else for me? Anything else that you worked on? Anything else that you would like to see? Yes, please.
So then we then came down to, so I got 4x squared.
Is that something similar?
No.
Okay. Very good.
4x squared.
4x squared.
Equals 320. And then
320.
yes.
Okay.
It has to choose the way you think is best.
Very good.
So I chose the one you square both sides and stuff like that.
Perfect, perfect. What I would have done from the very beginning, remember the two key words. What are the two key words in algebra or math?
Factoring and simplifying.
Excellent. I would have simplified first. I would have divided both sides by
2.
4, correct?
No.
Yes, that's fine. So this is x squared equals 80. This is what I would have done from the very beginning.
This is what my question came. So when you get to the square root of 80,
Yes, you have to do the same thing. Yes.
So how do you know which number two numbers to choose to find 80?
Very
There's
good
so
question.
many
Very good question.
numbers.
Here's one way. Here's one method. I will present the prime factorization. Prime factors. I will present 80 with prime factors, and then it will be very easy to figure out what comes out of the radical. So first of all, I have 8 and 10, and then I have 2, 2, and 2, and 2, and 5. So now this is very clear that I have a 16 to take the square root from. 2, 2, 2, 2, it's 16, and the square root of 16 is a perfect square. I mean, 16 is a perfect square. The square root of 5 stays at the square root of 5. So this is what I recommend. It's not that long, it's not that difficult to present the prime factors of a number. So now you have 4. 2, 2, 2, 2, this is 16. So therefore, I will write that x equals plus or minus. Remember, we only take the square root. It's quadratic. I have to find two solutions. Now, if this is a good reminder for you, write on the side somewhere, second degree, two solutions. Like we wrote for degree 4, for degree 3. It's okay if that's a good reminder for you. So then plus or minus, and I have the square root. You can write the square root of 16 times the square root of 5. So then x equals plus or minus 4 the square root of 5. So this is what I would do. Use the prime factorization and then figure out which factors will come out. Obviously, the square root of 16 is clear. The square root of 5, no one can simplify. 5 is not a perfect square. Good. Perfect questions. Thank you. These questions help everyone. And help me too, because I didn't get the chance to go back to the situations like prerequisites, like this one, the square root of 80. Very good. Anything else for me? Bless you.
Thank you.
Okay, so let's go back to this problem because we didn't finish it, and then hopefully finish up. Anything else for me? Okay, so then we have the square root. This was number 16. 6x plus 1 equals x minus 1. Again, we know so many different types of equations now. Linear, quadratic, polynomial, rational, radical. Which type is it?
Radical.
Of course, it has a radical in it. Always remember, just read the equation. Once you start and say radical or square root of, then you know what type it is, most of the time. Okay, very good. So can anyone give us the next step?
The square root of 6.
Right, why don't I cube? I want to cube. Will it work if I want to cube?
No.
No,
So
it will
cube.
not because the index here is 2. That's why I have to square. I can't cube or do anything else.
I thought you said, what do we do if I want to cube? And I was like, it's not
Yeah. I was being fun, trying to be fun. Okay, very good. Now, one very important note. Be careful not to do this mistake, perform this mistake. Look at this, for example. 2 plus 3, is that 5? What if I say 2 squared, 3 squared, 5 squared? I put a square on each term. Will that be true? Absolutely not. 4 plus 9 does not equal 25. So be very careful. You cannot just put a square here, and a square here. The left-hand side is considered 1 unit squared. The right-hand side is considered 1 unit squared. Is that clear? Good. So the left-hand side now.
It cross out.
So what do we have?
6 plus 7.
Very good. The right-hand side.
X squared minus 2x plus 1.
Awesome. This is our agreement from the first day of classes. Awesome. The binomial squared is a?
triangle.
Excellent. Very good. So what type of equation is this? Exactly. It is quadratic. How many solutions do I expect? Now you notice what happened here. We basically changed the radical equation at this stage into a what? Into a quadratic. Yes, exactly. But which is much easier to solve than that one. Very good. So how do I proceed?
You can subtract the 6x.
Yes, I move these two terms to the other side, of course. So I have x squared minus 8x, and these two go away, set equal to 0. If you ask me to choose from any possible quadratic equation, I would always choose this one without the free term. That's the easiest possible quadratic equation. Why? Because I will pull out a Wait, what was the question?
I was right.
That's
I
okay.
thought it was a statement.
That's, no, I was waiting for you to finish my sentence. I will pull out a,
That,
it's quadratic. I will pull out what?
two answers.
Okay, you tell me what you would do.
Pull out a perfect square.
No?
Not an x.
Exactly.
No, that,
That's why I say it's quadratic, but it's the easiest because it doesn't have the free term, and these two terms have a common factor, which is, remember these are the steps in factoring, right? What is it? Descending order, greatest common factor, negative leading coefficient, special product, right? And so on and so forth. So I will pull out an x. What is left in parentheses? Very good. So then you will give me two options, and they are
X.
exactly from the first factor, 0. Awesome. And 8. Good. What is that?
You have to plug it back in.
Right. It's part of the problem. Remember, I used the method that is not 100%. It's the only one. I have to use it, but it's not 100%. So I go back to the original problem. Careful, this is not the original problem. Not with the square, of course. The original problem is the square root of 6x plus 1 equals x minus 1. I will plug in first 0. Does the left-hand side equal the right-hand side when I plug in 0?
No.
No, because the left-hand side is 1 and the right-hand side is?
Negative 1.
Exactly. So I will say no way. This is what it's called extraneous solution. A byproduct. Something that happens to be in there because we used a certain method. So now when I plug in 8, 6 times 8 plus 1. So the left-hand side is 7 because the square root of 49 is 7. And the right-hand side is 7. And then I will definitely say yes on x equals 8. Any questions on radical equations? Any questions on radical equations? Do you think we are okay with radical equations? Yes? We can always come back once you start working on them, see what you get, and always remember, please always redo the problems we do in class first, as many times as you need, and only then start your homework. You will have much less difficulties, or maybe not difficult at all. No difficulties at all after you do that, please. Okay, the next type is problems 31 through 40. I don't have a name for this equation. They call it with rational exponents. Let's call it that. So equations with rational exponents. Equations with rational exponents. Bless you. So let's look at problem 34, page 185. So we had x plus 5. Everything raised to 3/2 equals 8. This is not a trivial equation. I recommend the following method. First of all, let me ask you, what do we need to get rid of? The exponent. That is the problem. This is the problem. If I manage somehow to get rid of that exponent, I will change it into a linear equation, right? If this is gone, then now this is linear. Not a big deal, right? But the problem is, how do I make that 3/2 disappear? So I have to apply a procedure to both sides. And it's very similar to radical equations, because a radical equation is pretty much the same thing. That's why I didn't really have a name for this. It's also a radical equation. It's the square root of x plus 5 to the third. Okay, so what I recommend is do it into 2 steps. In step 1, remove 1/2 power. Bear with me. I will have several examples. In other words, remove the denominator of this fraction. That's all I'm saying by removing 1/2. The denominator of this fraction. In step 2, remove 3, which will be the power, the numerator of the power. So first I want to eliminate this piece, and then I want to eliminate this piece. So like before, this is very similar to this, right? Removing the square root or removing power 1/2 is the same thing. So let me refresh our memory. The square root of x is the same with x to 1/2. What about the cube root of x? What will that equal to?
X to the 1/3.
Exactly. And this is how I also put them in the graphing calculator. I know there are many options, several options, but for example, if I want to determine the square root of 4, I have this option with a square root, or I can write 4 raised to the power, in parentheses, 1/2. That's what it means, the square root of 4. And yes, please.
So we're removing 3, what would cube root both sides?
Say it again.
We were
And then after we remove the denominator, we will take the cube root. We apply the cube root.
for both
Excellent.
sides.
Yes, excellent. Okay, so which is 2. So now if I want 8 to take the cube root of 8, this is what I will do, power 1/3, because that's what the cube root is. Now I know we have here in math, we have the cube root and we have the square root. And some of your calculators and newer ones may allow you to put in the index, any index you want. That's possible. Not this software. Okay? So in order to remove the 3, the 2, 1 or 1/2, then I will have to do what to both sides? If this is the same with the square root, we will have to raise both sides to which power? To remove this denominator. 2 indeed. Because 3/2 times 3/2 times 2/1, remember, will be 3. So then this is x plus 5 to the third power equals 8. Remember, we squared both sides of an equation. What do we need to remember, not to forget if you want to do? We squared both sides. What do I have to do for sure at the end? When we square or cube, go back and check. Go back and check. And yes, now in order to remove this power, we have to apply the cube root. The left-hand side is?
X plus 5 cubed.
But we apply the cube root, so it's x plus
yeah.
5. And then the cube root of 8 is 2. So then x equals -3. Of course, it comes with question marks.
Quick question.
Yes.
On the homework, this is not how they do it.
Oh, they are using a formula. I don't recommend the formula, but if you want to use it, I'm fine with it. So here's the formula on page 179 at the top. Yes, please.
No problem. If we raise both of them to the second power, why do we change?
Sorry about that.
Then square it.
Of course, I was just sorry. My mistake. My apologies. Of course, I looked at the left-hand side. I was talking, and no excuse. Of course. So this is 4. So then this is -1. Thank you very much. Thank you. My apologies. Of course, I have to square both sides. I can't pick and choose. Just one side will not be correct. Sorry about that. So here's the answer. Tony's right. So your book shows something like this. They say, raise both sides of the equation to n over m if m is even. Raise to n over m if m is odd, and then it gives you 2 different situations. I try to avoid memorizing something like this. If you always remember to eliminate the denominator of the power and then the numerator, you will never have any difficulties.
No, what I'm saying is, when they have the exponent, they just write the reciprocal and put it on the other side.
Correct. But that's the problem. Sometimes it's plus or minus, sometimes it's only plus.
That's what I'm,
So I don't recommend this method. Because then you have to remember, if m is even, then you have to put plus or minus. If m is odd, then you will only have plus. So that's the difficulty in this method. Or you remember the following steps. You have a fraction as the exponent, eliminate the denominator first and then numerator, and you will never have a problem. Because otherwise you have to remember this concept.
but if you said if it's negative,
If the denominator is even, then you have to put plus or minus.
okay.
If the denominator is odd, you only have plus. So it's up to you if you prefer that. It works. It works. Okay, so let's look at very good question. Thank you. Tony's always way ahead of me. He can't wait for me to present anything. Just kidding. It's awesome. That's well done. Okay, so let's look at 38 as another example. X plus 5 again. I really didn't want x plus 5 again, but that's it. Okay, never mind. Oh, we didn't go back and check. Sorry. We have to go back and check. So this is x plus 5 to 3/2 equals 8. Now I plug in -1. How much is -1 plus 5? 4. I know I wouldn't do this with a graphing calculator, but let's do it now. So 4 raised to which power? 3/2. What should I get if this is correct? I should get what? Very good. Let's see if we get 8. So we checked. We put 4. Because -1 plus 5 is 4. 4 raised to 3/2. It turns out to be 8. So therefore, we accept -1. We understand why we had to check, correct? Because we raised both sides to a power. Good. So the same thing here. So check. Now, I'm looking at the time. Just 1 second. Okay, I'm fine. If you eliminate the denominator first and then the numerator and think every step of the way, you will not have difficulties with this. So let's eliminate the denominator first. The denominator of the fraction. How do I eliminate the denominator of the fraction first? What do I have to raise both sides to? Excellent. So then the left-hand side is x plus 5 to which power?
Second.
Awesome. And the right-hand side is?
64. And then you square it.
Now I have to think for a moment. When I take the square root or apply the square root to both sides, what do I have to write? What type of equation is this? It's quadratic, correct? So this one is quadratic. So then how many solutions do I have to write? 2. So always ask yourselves, like I'm asking you, like a broken record, what is this? What is this? What is the next step? So when you solve these problems, do the same thing. Just ask yourself, okay, is it quadratic? So I'm expecting two solutions. So if I'm expecting two solutions, then when I take the square root, I have to write x plus 5 equals plus or minus 8. So then x equals -5 plus or minus 8, and we have two options. And I have to separate them. So -5 plus 8 will be
-5 plus 8 is 3.
perfect. And -5 minus 8 will be, of course. Careful, keep an eye on my numbers today. Okay. I raised both sides to the third power. I have to go back and check, but do you expect both solutions to work? The answer is yes, because the power is odd. Yes. So I expect both to work in the original problem because I raised it to an odd power. When I raise it to an even power, anything can happen. I don't know if they're going to work or not. And when I raise it to an odd power, I still have to check, but they will have to work. Okay, so let's try 3. 3 plus 5 to 2/3, and I want to see if this is 4. And -13 plus 5 is -8 to 2/3. Okay, so 8 to 2/3 and -8 to 2/3. 8 to power 2/3. I'm expecting a 4. And in parentheses, do not forget, in parentheses, -8 raised to power 2/3, also parentheses 2 divided by 3, because it's an operation. And the answer has to be 4. And that happened because we raised both sides to an odd power. That will always be true. Okay. We have to look at 2 more. And then we can continue with something else. 2 more types. Okay, I'm sorry, I didn't write. So this is 4 and this is 4. Check, check. Okay, ready? The next type is a little bit more, even more difficult, I would say. And this one has a name. We are going to use a substitution. The name of this new type of equation is called equations quadratic in form. What is that? Equations quadratic in form. So they're not quadratic, but they can be replaced by a quadratic equation. And what's the use of that? Why would I want to do that? Because solving a quadratic equation is not difficult. Furthermore, we have 4 different methods. So I could, at any point in time, be more than willing, I would say, to change anything into a quadratic, because there is no problem. I will be able to solve it. Not all equations are quadratic in form. So let me give you a few examples of equations that are quadratic in form. Okay, so let's start with a 42. Same page, 185. X to the 4th minus 13x squared plus 36 equals 0. And you should say right away, what are you talking about here? This is polynomial. It's a polynomial equation. And the degree is?
4.
Right. So how many solutions will you get? 4. Always 4. So if it's degree 4, 4 solutions. True, but I can't factor this. So here's what I'm going to do. I'm going to look at this piece, and I'm going to look at this piece. Which of these two has a smaller power? I know it's silly, but I just want to show you what we have to do first. X squared has a smaller power. I'm going to say let, and give me any letter you want other than x. Let this letter be x squared, the smallest power.
B.
B. Awesome. Lowercase b. Perfect. Now, remember what the title is. Equations quadratic in form. This equation is quadratic in form only if this quantity can be replaced by
B squared.
exactly. Otherwise, it's not quadratic in form. But I can't force it. I want to make sure that this is true. If I denote this piece by b, is this piece b squared?
Sure.
It is. Because when I squared x squared, I copy the base, and what do I do with the exponents?
Add it.
Multiply. When we raise to a power, we multiply. So the original equation, x to the fourth minus 13x squared plus 36 equals 0, can be replaced by this if we perform or if we use this substitution. If I call x squared b, then this is the new equation, which I know how to solve by factoring even. So we used the substitution b equals x squared, or b squared equals,
X to the fourth.
excellent. Why? Do I have to do this? No, unless you can factor it, and we can really look at this right away and say, oh, I know how it's factorable, and how do I factor it? So we are trying to make our life easier by using this substitution. Why? Because this I know how to solve. It's a trinomial, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, no. I could write b plus 6, minus 6, right? I could write b minus 6 everything squared, but what is the middle term here?
Maybe 12.
Yes, this is negative 12b, so it's not a perfect square. But 1 is the leading coefficient. That makes it easy. So then can anyone tell us how to factor? Now, at this point, do you have to factor? No. If you want to use the quadratic formula, use the quadratic formula. That's fine. How do I factor?
B minus 9 times B minus 4.
Awesome. So there are two options for b. And I forgot, we already talked about it, and I skipped one little step. I mentioned it, but I didn't write it. What is the degree of this polynomial?
4.
How many solutions do we have to write? 4. So degree 4, 4 solutions. So we don't forget. Very good. So there are two options for b.
Negative 9. No,
Careful.
Negative 3 and 3.
Careful.
9 and 4.
Do we all agree with 9 and 4? So b minus 9 equals 0 means b equals 9. And b minus 4 equals 0 means b equals 4. Everyone with me? Okay. However, don't cross it out like that. I'm just trying to make a point. This is not what I'm solving. I have to go back to my substitution. What was b denoted by? Or what was b? What did b represent?
X squared.
Exactly. It's x squared. So this equation is x squared equals 9. And this equation is?
X squared equals 4.
Correct. Now I'm back to quadratic again. And I know which method is the best here in both cases. And how many solutions will I get from each?
2.
2 from each because they are quadratic. Awesome. Which method is the easiest to apply?
Square both sides.
Exactly. Taking the square root. Very good. Remember, we have to get 2 solutions from each. What will you get from the first?
3 negative.
Exactly. And what will you get from the other?
2. Oh, plus or minus 2.
Correct. Very good. 4 solutions. That's why I wrote myself a note. Do not forget. 4, degree 4, 4 solutions. So one more time. Why was this possible? Because it happened that the equation was quadratic in form. What does that mean? It can be replaced by a quadratic equation. Why will I do that? To make it easier. Do I have to? No. As long as I am able to write from here, here with x squared minus 9, x squared minus 4, I don't have to use this. I highly recommend it though. Any questions for me so far?